Are you sure you're in the right room? I think you're in the wrong room. There are some chairs on the other side. You can grab some. This is my third time in DefCamp. If you've been to my other talks, you should know that you should get coffee first before you attend my talk. Otherwise, you'll be falling asleep in the middle of the talk. See, they're on the side, they're ready for my talk to sleep. See? Some of them, they have some. How many been here to my talks before? See, the rest decided not to go again. So we're going here to look into how to hijack the boot process, ransomware style. We're going to actually look into how Petya override the master boot record, and at the same time, I'm going to show you how to debug the boot process, how to debug the master boot record. Oh, it's not working. Okay, since everybody's new to my talk, okay, this should work. Okay, about me, I work at Fortinet from Vancouver, Canada, so I applied over here, and I think I'm the only Canadian here so far. And I published some of the articles in Virus Bulletin. If you want to look into some free articles, you can just search my name. And I post some of the blogs in Fortinet, blog.fortinet.com. That's the sales pitch, okay? I put some, those are some of my conferences that I presented to, and normally, okay, that is my profile pic, but deep inside, as I've said last year, okay, this is actually, that's my actual profile pic. This is stenography, right? Anyway, okay, before, just some of the basics. If you've been living for a while, you should know that there's something that we call floppy disk. There's a bigger one, 5.25, and one 3.5. Before we had those things, we can install so many apps like chess and everything and any other games. But now, you cannot use them anymore because just one apps, it will need lots of hard drive. But before that, actually IBM created this guy. Okay, this is a 1 gigabyte hard drive. It is actually 75 pounds. Okay, imagine if you want to have 2 gigabytes, you should need another 75 pounds. But now, okay, you can actually buy 1 terabyte, which is equivalent to 1,000 of this. Imagine carrying that to your workplace, right? Or you can have this. You can actually have so many gigabytes. Like this one is 256 gig, and then you can have put them in your pocket. Okay, just for the trivia. But every hard drive that we have, the floppy and the hard drive, we have what we call the very first sector. This guy. Okay, it is sometimes called the 001, cylinder 0, head 0, sector 1. That is what we call if you're using the hard disk, you call that the master boot record. Okay? And if you're using a floppy drive, it is called the boot sector because there's no other way to boot from something else. Okay? And then the master boot record usually have, or the hard drive usually have different partitions. Okay, I'll show you first how to create an MBR GPT partition in Windows. Okay, at first, those are the different kinds of partitioning, the MBR and the GPT. This one is for the new ones. Okay, MBR is for the old version of your BIOS. Okay, it always contains, one of them contains the master boot record, but this one for backward compatibility, we call that the protective MBR. It is not actually protected, but they still call it the protective MBR. So you have the GPT GUI partition table. Normally, if you have a new computer, you have the UEFI, okay, wherein it's some sort of software in your BIOS that checks for your system, okay, and then it includes those things, and then it only works on the GPT, okay, and then second and the last sectors contains the information for your GPT hard drive. Okay, you can use a disk management tool wherein you can now set up your hard drive. You can check. You can use that one to create your MBR or your GPT. Okay, so for example, this one we created this particular drive. So I have two drives. I created this as an MBR, and then this is how you make a GPT. Okay, but if you happen to ask it to created an MBR and GPT, and then you decided to change it, you can actually just change it to the same using the same disk management. There's a part of the menu here is you can change it from MBR to GPT or vice versa, GPT to MBR. So those are some of the basics for the hard drives. Okay, if you're going to look at the partitioning is because most of the time you want to have different partitions in your hard drive. Okay, if you want if you're using an MBR, you can only partition your hard drive into 4, but the rest are extended. That means you cannot really extend your partitions using MBR. But those are what we call the extended partitions or logical partitions. But for the GPT, they remove that restriction. Okay, you can now create as many partitions as you want. That is for the GPT. So if you look at here, okay, as long as your hard drive can handle your partitions, it will work. Okay. And then another tool is it is a command line. You can use this part to check if your hard drive is GPT or not. If it is a GPT, there's just an asterisk. Can you see it? It's like a dot, an asterisk that denotes it's actually a GPT disk. Okay. But again, at the same time, even though you're using GPT or MBR, they always have the per sector. Okay. I'm always focusing on the per sector. We're going to look into that later. Okay. MBR disk, it talks about cylinder head sector addressing. This one is LBA, illogical block addressing. They don't compute for the heads. And there are some conversions that you can see online. Okay, how they compute the LBA converted to CHS. Okay, those are some of the intro. You still have a chance to go. My question is, what kind of malware that you can bring home and make it a spread? I'm just a joke. It's supposed to be this one. A petya. A petya is actually one of the ransomware that not only encrypts your files, it actually attacks your master boot record. Remember, we're talking about the first sector. It attacks the very first sector of your hard drive. Okay, but before we go that, okay, this is actually what happens when you run or execute a petya if you happens to have the malware. Okay, okay, this particular set of codes from here to here. Okay, the main purpose of that code is only to decrypt 4 bytes. Okay, if you try to execute that, keep going and going until you reach this one, you have the 4 bytes. And petya is kind of a big set of codes, so it will take you lots of time just to decrypt the whole thing. But all you have to do is to go to the end, put a breakpoint, that's it. You're done with the decryption. Okay, it creates an NZ PE. You can tell that it created a new file. Okay, because of this. Okay, this will be after the decryption. You will see this. Okay, and then it checks if it is a valid MZP header. This is the PE 4550. This is the checking. Somewhere there's the checking for this one. 5A4D is the checking of the MZ. It just wants to make sure that it actually decrypted the executable, the new executable. Okay, and then within the code, it actually gets the library, the APIs that it needs. Okay, this is how it turns out. Okay, from this, it created from the hashes. Okay, it gets the API that it needs to execute the whole malware. Okay. These are the rest of the API aliases. You know APIs, right? They are the one that connects to your shared libraries and so on and so forth. Okay, you can actually see here that it is malicious. API itself is not malicious, but the combination of those APIs like this okay, you know that it is going to encrypt sometime, right? Okay, after that, in the section more technical is you're going in the malware looks for the XXX section wherein it actually contains the skull. If you know Petya, there's a skull ASCII art here, and there's a ransomware notes here. Okay, that is actually contains in the .xxx section. This is the .xxx section. This is the simple XOR decryptor to generate the strings, and later we will see the actual skull. This is just the ASCII dump of the whole malware. Bootable disk. What is a bootable disk? If you want to create something, if you want to create a malware, I'm not saying you create a malware. If you create, let's say, an application to access your hard drive programmatically, okay, you access it. You call the device IO handle, a device IO control. That is on the first API to access your hardware. Okay, and then usually you use the create file. Okay, the create file is actually the one that opens your hard drive. So execute the device IO control API, call the create file API, and then voila, you have access to your hard drive. Okay, this is how you do it. These are the parameters that you need in order to physically access, or not physically access, programmatically access your hard drive. Okay, how do you know that it is actually the master boot record? Let's see. Device IO control, okay, these are the parameters. This is, you can search it online. You can see this. Okay, all you have to do is to check this. Okay, there are different IO control code. This one, it checks if this one only checks if there is a hard drive, if you can access the hard drive. Okay, the initial calls to create file A and device IO control is just to check the malware, the Petya is just checking if the drive C or your first hard drive is accessible. If it is true, it will now check for the physical drive 0. Physical drive 0 now is your first drive, which is your drive C. Okay, you can have as many drives or hard drives in the system, but all you have to concern yourself is the first drive, which is physical drive 0. Okay, there are different ways that you can see that it is a physical drive 0. Okay, in different ways, it is sometimes called DR0 or DR1. Okay, for backward compatibility, it uses partition 0, hard disk 0. Those are the things that you have to remember if you're trying to access your first drive. Okay, and then you have this, the global physical drive 0. There are different things, but they are all pertaining to the first drive, which is the drive C. And then at the end, to open it, okay, you have to just create file, call create file A, physical drive 0. There's a tool in Windows, we call that the WinObj. You can actually tell if you have the drive 0. You can actually check if the drive 0 exists. Okay, these are the things that you need to see. Okay, physical drive 0 or the hard disk, you use the WinObj. Okay, it actually came from sysinternal. Sysinternals is a pre-collection of tools that you can use in order to monitor your system, to check your system and everything. Okay. Again, this is how Petya call the drive 0. Okay, device IO control, the IO control code. Okay, the IO control code 748 is actually, it is now checking what kind of partition. Is it an MBR or is it a GPT? Okay. From the partition information, you can actually say if it is this one, another kind is raw information, and then so that is how Petya authors, they are actually good programmers. They actually can access your system. They know how to check. Okay. Okay. There is another tool from sysinternal. We call that the process monitor. You run process monitor first. You run the malware, you will be able to see if it is actually accessing your hard disk. Okay? You have the create file. I filtered the rest of the APS, but when you run process monitor, it will tell you lots of informations, okay? But this one is actually, this particular part tells you that it is actually getting the, or opening the hard drive, okay? So you run process, you run that one, then you'll be able to see. Another thing, we can look at the code, okay? Okay, this is now how it overrides your MBR. At first, Petya reads your MBR, the master boot record. Second, it executes a series of instructions where it uses the create file, it opens the hard drive, set the file pointer, it points to which sector. It's actually, it doesn't just infect your MBR, it infects the rest, some of the sectors, because it wants to place the code in your hard drive. Okay? And then it is actually just using a simple encryption, which is an XOR 37. Okay? It XOR, if you see that in ASCII, 37 is number 7, right? And then again, it creates a file. So this is what happens. It opens the hard drive. It points to which sector you want. It reads that particular sector. Read file here is now reading the sector. Okay? It reads, it encrypts. Again, it opens again that particular hard drive, set again to the exact location, and then write your encrypted version of that particular sector. And then after writing this one, from sector 1 to sector 21, sector 1 is not the MBR, sector 0 is the MBR. Just want to make sure, right? So this is sector 0 is MBR, sector 1 to 21, this is what it does. And then now it writes the new MBR. The new MBR is the one that we will see later when we run the debugger. Okay, and then writes the small kernel code starting at sector 22. Those are the information that it needs in order to execute the malware. Basics for the MBR. Okay, one sector is only consists of 200 bytes, 200 hex bytes. Starting here is the bootstrap. This particular part contains this is the MBR. It only has 4 partitions. It will tell you which partition are active, and then this is the marker for that particular boot sector. Okay? Those are the information that it needs. Okay? Again, using the process monitor tool, okay, you will now be able to see that it is trying to read the MBR because of this. The length 200 is one sector. Offset 0 is your MBR, okay? And this is what happens. This is the marker that is actually, it gets your MBR, and if you have this, if you check this one, then that means you have the actual MBR for the boot sector. There is another tool, we call that the Hijacking. You can download it somewhere, okay, online. Okay, you can actually use the same tool, Hijacking by Demio. Okay, you can actually read the contents of your hard drive. This is not the malware. Okay, this is just the tool to help you read your hard drive. Okay, you don't actually need to program because you can just get this one. If you want to read the MBR, put 0 here, get the first sector, and this is your output. Save the sector to file, and then you will be able to see that it is actually the MBR. This is the one that looks like a regular MBR. Okay, later you will see a difference between the infected version and the regular version. Okay, that is from the Hijacking tool. This is actually the code from Petya. Okay, Petya reads your MBR, right? So the same thing happens. Okay. And then the second process, it reads, it encrypts, it writes, this is that code. This is what happens to your MBR. So you run this code, this is what happens when you read the content of your hard drive. Okay? And then again, using process monitor, okay, you will be able to see, just running the malware, you will be able to see what is going on in your hard drive. It creates, that means it opens, it reads, and then write it back, which is already encrypted. Next, it writes the new MBR. Look at this. This is the original MBR. This is the partition information somewhere here. Okay, but when it is infected, it becomes like this. There's nothing in the middle. That means on this particular point in time, debugging the malware, your MBR now is encrypted. At this point, you might not be able to recover your system. Right? My talk is not how to do the solution. My talk is how for you to do your solution. Okay? I'm just giving you the set of tools in order to do that. My research is for your base. The new MBR code is actually this. Okay? We are going to see that in the debugger. Okay? This is might be your first time to see how the boot process actually works. This is actually my favorite part later. Okay? We're going to see the code. Okay? Again, going back to the first set, the first sector of the MBRs, the master boot record, the first sector of the GPT is the protected MBR. For Petya, it doesn't matter. It will still be infected. So it doesn't matter. It doesn't protect you whichever kind of partition that or whichever kind of hard disk you need. You're still gonna be infected. Okay, this is the continuous writing of the sectors. Okay, it is now the point at sector 22. It is now writing the malware code, the kernel. We call that the mini kernel because if you run your computer, if you don't know what's going on, the first time you turn it on, okay, it will check first if you're going to use Linux or Windows. Okay, that is what's happening. If you're running Linux, okay, you won't be able to see that it doesn't know at first. Your system, your computer doesn't know if it is running Linux or Windows. That is what happens during the boot process. The boot process actually decides if it is Linux or Windows. Okay, and then if you are infected with Petya, okay, your computer doesn't know that it is infected with Petya. Okay, it will still execute whatever is the available kernel. Okay, so now actually Petya is kind of a whole operating system because it is actually executing itself, the kernel. It is now its own kernel. This is what happens inside the sector 22. Okay, you will see that it continuously using the HD hacker tool. You will be able to see what is the content of your hard drive. Okay, and somewhere in sector 36, okay, you will be able to see the onion address. I put asterisk here, so you don't need to go there for your curiosity's sake. Okay, I don't want you to get infected or somehow something. Okay. But this is the address wherein you go there, it will tell you how to pay your Bitcoin, how to use your Bitcoin to pay for your infected system. The problem with Petya infection is, unlike other ransomware, if you're infected with ransomware, you can still use the same computer, pay the Bitcoin, put the code, and then you're done. Okay? If the ransomware will really decrypt your file. But this one, if you're infected with Petya, you need another computer because it doesn't work anymore. You need another computer to go to this onion address, pay your due, and then go back to the infected computer, okay, and put the code that they will give you. Okay? That is a very complicated one. So if you're a regular user infected with Petya, you need to go to your neighbor, borrow the computer, pay the Bitcoin, and then go back to your machine. Okay? This is what happens when when your machine is infected. If your machine is infected, if it reboots, that means it's done. Your machine is done. Okay? At first, it escalates the privilege using this particular set of APIs. Open process token, lookup privilege, open process token again, adjust the token to a higher level. Okay? And after that, it triggers another API, which is what we call the anti-race hard error. That is an API to reboot. You don't need to press your computer to reboot. It will reboot itself because Petya needs to reboot because when the first time the system runs, okay, you run your Windows, right? So the Petya kernel is not yet activated, so that means it needs to execute the kernel. That means you need to reboot. Okay, let's now do the reboot. Before we do the reboot, this is now your debugger. BOCH, I don't know how to say it, Box or Watch. Okay. You can download them online for free. Okay. Thank you for the creator of Watch. It is actually an emulator where it emulates x86 computer. That is now your debugger. We're going to debug the actual boot process. It runs all those programs. For example, you love an all those program. It doesn't work on your higher Windows system. You can run this one. It debugs MBR code. Okay. When I'm doing this research, I have to step F7 to do the code. I have to step 5,831,159 times. Imagine I pressed that much in order to see the actual code at 7600H. Imagine I think I did that for 3 months just pressing that step into 5 million codes. And then finally, I get the code. That is, it's running the kernel, Petya kernel, okay, which is the bootstrap. Actually, you can just breakpoint on 7600. After 3 months, I decided just to breakpoint on this one, and then now it starts the initial reboot. Okay. Again, the Petya code is here. We will see that a bit later. Okay, this is the interface for the box. Sorry for how we say it. Okay, this is the regular registers that you see when it's going. The problem is it is not very interactive, so you have to refresh every time to see the changes in the registers. This is your debug window where you press. This is where I keep pressing. Okay, 5 million times. Okay, in order to do that, this is your debug window. Okay. Okay, remember when you run the boot process, you don't have Windows yet, you don't have Linux yet. That means no APIs is running yet. There's no shared DLL, no everything. That means it only uses interrupts. Interrupt 13, function 42 reads the sector. Okay. It uses interrupt 10 to initialize the screen. Of course, it sets up the screen before it flashes the scary part. Okay. Reading this, interrupt 13, somewhere in the code, there is what we say this address packet. It gives you information which sector is being read, which sector is being written to, and so on and so forth. Okay. And these are the information that Petya needs in order for it to execute the boot process. Okay. Within the boot process, you will be able to see how it lets the 200 bytes, change it to boot sector, change it to this one, and again, we'll be able to see that one later. Okay. It reads this one, jump to 1597, then execute this code. Okay, remember we are now looking into the Petya kernel, the execution. The problem again with debugging the MBR is it is not very interactive. You cannot put comments and label, okay, and you need to constantly refresh the code window. Okay, this is how the codes that is used to activate the screen. It flashes the video screen. Okay, this is how I'm just showing the overview later. For that, the video there will be a video demo. Okay, it reads the MBR. It places it to 7760 buffer. Okay, this is the part where it contains the addresses. Okay, it's still blurred yet. Okay, I blurred also the hex bytes. Okay, so you won't be able to get the ASCII code. And then, okay, before when it runs, it checks if the system, Petya checks if your system is already infected. by just checking this particular byte. If this particular byte is 1, that means you're already infected. If it is not, it will try to encrypt your code. This is not the demo. Okay, on your left, on my right, okay, that is the simulated screen. Okay, your computer when it starts, of course, you have the screen. Okay, this is your screen. This is your debugger. Okay, where it is going to execute this one. Okay, the funny thing with Petya is, okay, this is the code wherein it outputs your character per character. Okay, showing this. It will look familiar to some. This is actually the CHKDSK, right? Check this. It looks like a check this. It looks like that it is actually checking. Take note that we are now running Petya, okay? But it will look something like this. At this particular point, if you're still seeing this one, it haven't encrypted your whole system, but it is already encrypted the master boot record. It is not trying to encrypt everything. It is actually going to encrypt your system. Okay, Petya does not encrypt the actual file. It encrypts the information of the file, wherein it is located in MFT, the master file table. It doesn't encrypt your file, it encrypts the master file table. Okay, you will see something like this. Okay, it actually do not interrupt the process, because if you interrupt the process in the middle of the encryption, and then if you happen to find out that there is actually a solution for your Petya, okay, you won't be able to get your whole computer. Okay, you have to let Petya finish the encryption. Okay, otherwise you won't be able to recover. If you happen to, there's actually a solution for Petya. You can search it online. But if you happen to be infected, do not interrupt the process, because it is somewhere in the middle. Because if you interrupt the process, you try to run the solution. Okay, half of the process will be decrypted, half will be encrypted, because you did not encrypt the whole thing, right? So let the malware finish first. Okay? So that is the initial display. Okay, it shows you the fake FDIS. No, not CHK, not check this. It is actually the fake. Oh no, I think I made something wrong. It should be fake check this, right? Just ignore that part. Okay, and then what happened next is it marks now your byte, which is now the encryption marker. Then writes back the sector 36, which is the Petya, right? The Petya addresses. Okay, this is how it writes the information back. Okay, there's and then it looks for the active partition. The MFT table is in the active partition. It is not in the MDR. Okay, it goes to the MDR, look for the active partition, go to the active partition, and then encrypts the MFT. That is what happens to. You can actually recover your file because the file itself is not encrypted. Okay, if you grab your hard disk from your machine, run some other tools, you can actually grab the file, the actual file. But the information on the file, because every time you put a file in your hard drive, in your system, it puts a record, which is in the MFT. Okay, the MFT is the one being encrypted, not the actual file. Okay, it first reads the two sectors, and then the number, the percentage is based on how many sectors it is actually used, the system actually used in order to put the MFT. Okay, for this particular instance, it has 32,320 sectors that contains the MFT. Okay, it displays the initial counter. Okay, this one. Okay, this is the code that put those information. This one is the number of sectors already encrypted. This particular part is the number of sectors that contains the MFT, and is just showing the percentage. Okay, and then after reading this one, this is the normal MF3 entry. This is file 0, file 1, you can see those things. Okay, oh no. And then if it is after encryption, you will see something like this. Okay, it is unrecoverable until you get your actual decryption. Okay, this is how it tries to do the routine. This is the part where it shows the percentage. This is the function that treats your sector, the 8 sectors. This is the function that encrypts your sector, the MFT sector, and then this is the function that writes it back to the code. This is what happens when you run the process. You are actually running the kernel fetcher, right? This is, I'm showing you the contents of the MFT. Okay, that's for the file, and then later I will show you, it will show you how it is encrypted. So running that particular part and then write it, okay, showing it back, refresh again. I say you have to keep refreshing. This is now the contents of the encrypted MFT entry, okay, and this is where it runs the process. It takes a while, okay. You have to be patient. You have to let the malware encrypt your system. Probably you can grab some copy and then while waiting, and then fast forward to the future from 1% to 100%. See, I have the power to fast forward. See, 92%. Okay, and then I'm done. Because I'm done, I will be able to at least decrypt if I get the solution. I'm not showing you the solution. I'm showing you how to debug, how to do research on your own, or how to attack this particular kind of malware. This process, this procedure does not only apply to Petya, it applies to, probably you can apply it to a different version of Petya, the Misha, the Golden Eye. You can also apply it to probably the Bad Rabbit, that's a new ransomware. I think it's another version of Petya. I haven't seen it actually, because I'm here. Booting from hard disk, this is now this one. This is now the part where remember, it reboots the first time in order to run the kernel. Once it encrypts the whole thing, the whole MFT, it will reboot again, okay, to show you this very part. Okay, first, this is the second reboot. This is what happens after the second reboot. It analyzes the video screen, reads the sector 36, checks the marker, and writes the characters. This is the second reboot. Okay, when you run the second reboot, it is not going to encrypt your system anymore, but it is going to execute this. Done. Okay, what happened? Okay, it uses interrupt 10, okay, because it changes the screen color to red. Okay, it is now going to start writing some strings, some ASCII. Okay, there is actually step-by-step instruction on how it shows you the main show, right? This is actually a hat for the Halloween, but it's November something already. Okay. Okay, the good thing with not the good thing. The thing with ransomware is, unlike other malware, as I keep saying this, unlike other malware, for example, a Trojan, if there's a Trojan, okay, sometimes it is already stealing your information, but you don't know that is you are infected by the Trojan. The thing with ransomware is, if you're infected with ransomware, you will know. At least, right? Okay, that is now, when I press the enter key after the ransomware, it will give you the message. Okay, it will tell you which address. Again, if you're infected with Petya, you cannot use the infected machine. Go to your neighbors. No, not infected. Okay, and then you will need, but you have to memorize this, right? Because you need that to enter to the information. Okay, I tried putting some keys. It will give you some keys. I tried my name, doesn't work. Okay, I tried the system. I run somewhere, execute somewhere. Okay, I tried again my name. No, that's not my name. I tried again my name. If you have the actual key, if you have the proper key, this is the thing that you should see. That one. It's not should be decrypting your sector. I did not get the actual key. I just keep, because I have control on the debugger, I just keep on the, just for the show, that is actually decrypting. And then if you have decrypted the whole thing, okay, you can now, it is now asking to reboot your system. Remember, if you are infected with Petya, and then you are in the middle of encryption, you interrupt the process, and then you get the solution. When you run the solution, the decryption key, it will decrypt up to the part where it is encrypted, and then it will encrypt, not decrypt, it will encrypt the one that is not encrypted previously by the malware. That's why you have to wait for the malware to finish its For the conclusion, okay, this is now Petya for the stage 1. It runs your system, creates the MBR, mini kernel. Okay, of course it displays the fake FDIS, encrypts your MFT, initiate the second reboot, displays the skull, and waits for you to pay. Okay, I am not advising for you to pay because it's not actually 100% that you will be able to get your system back. And these are the tools that I use. These are open source too. That means you can grab it online. I didn't put the link because I might give you the wrong link. Okay, if you're infected, at least it's not my fault. Okay, so I have this management. These are some free tools from SysInternal. You can download this, and I think these are the SysInternals. This is the debugger before. Okay, yeah, I used two debugger. The debugger before the writing, okay, and then the debugger when you're running the boot process. And that's it.